Okie doke, let's blast through this practice quiz since everybody is asking about it. Okay, so composition of functions and sequences. That's covering day 1, day 2, day 3 of everything, right? So we're talking about composition of functions, restricting domain for inverse functions, maybe like 1-to-1, right? We'll also talk about sequences, so explicit versus recursive, arithmetic, and geometric, yeah? Okay, so here we go. The first three terms of the sequence B sub n are given below, 54, 46, 38. And we ask ourselves, is the sequence arithmetic, geometric, or neither? Well, if it's arithmetic, it has a common difference. So what I'm going to put this here. I'm going to say star arithmetic. This would be a common difference. And if it is geometric, then it is a common ratio, meaning you are multiplying by something, right? So difference, add, subtract, ratio, multiply, divide, yeah? Okay, so let's see. From 54 to 46, we'll test out common difference first. That looks like -8. And then from 46 to 38, that also looks like -8. Okay, so that's a common difference, it seems. Based off the given information, looks like that's a pretty safe approach. I could double check for, let's see, let me do 46 divided by 54, get 0.85, 38 divided by 46. Nah, they're not the same. So definitely not geometric. Definitely not. Okay. So, well, it's arithmetic. Ooh, I said arth. I say arithmetic. Since there is a common difference. Oh, this is taking me years to write. Common difference of 8. I should say -8. Okay? All right. What's the recursive formula? Okay, well, two aspects. First, you need to give the initial value b sub 1. You need to do that. That's 54. If you don't do that, I'm taking points off. Hint, hint. Okay? You have to start the sequence somewhere. And then you have to create some relationship between b sub n and the term before it, b sub n minus 1. Well, if the common difference is just -8, the current term is just the previous term -8. That's it. And we move on because that's the recursive formula. And often I like to put a little bracket like that. You don't have to, but I like to do that. Okay, now let's write an explicit formula. So explicit formula, remember, is something that I can just plug in or substitute in, and it'll tell me what it is. So this is arithmetic, which means b sub n is the first term, b sub 1, plus the n minus 1 common differences. Well, that means b sub n is the first term, 54, plus n minus 1 times the common difference, -8. Which, if I like, I could distribute that -8. You don't have to do this, by the way. 54 minus 8n plus 8. Looks like that's -8n plus, oh my gosh, 62? I didn't mess that up, did I? Okay, yeah. And so now we're just going to plug in b sub 31. So that's -8 times 31. By the way, finding the explicit formula is part of this question. You may be able to find the 31st term without this. Part of the instructions are to write the explicit formula, so please do so, okay? Just grading expectations, that's all. So let's see, I'm going to take my little calculator here. -8, because I don't have a key. -8 times 31 plus 62. It took me years to write into my Desmos calculator. Okay, -186. And I box it and I call it a day. And I move on. So the first three terms of the sequence R sub n are given below. 3, 1/2, 1/12, and so forth. So I check for a common difference first, right? I mean, you don't have to. You can try anything first. Let's say 3 minus 2.5 is 1/2. Is 1/2 minus 2.5 1/12? Nope. So it's not a common difference. So, okay, it's not that. So say, is there a common ratio, right? Could I multiply 3 by something to get 1/2? If I multiply, I know that 3/6 is a half. So if I did 3 times 1/6, wouldn't I get a half? I would. If I did a half times 1/6, would I get 1/12? Yes, I would. So it looks like there's a common ratio of 1/6. Geometric, because common ratio of 1/6. Okay? I'm multiplying by 1/6. That's the common ratio. Let's write a recursive formula for R sub n. So we tell the first term of the sequence is 3. And then, sorry, I hear people outside. Got a little spooked there. They were being loud. And then R sub n is, I take the previous term and I multiply it by 1/6. So it's 1/6 times R sub n minus 1. And that's it. And now I want an explicit formula. So since it's geometric, I know that R sub n is the first term times the common ratio R. I guess I didn't use the best letter here. I'm going to say, laugh out loud. That's silly. Oh, that's confusing, Mr. Spake. You shouldn't have used R. Okay. Whoops. That's fine. It's not a big deal. So then R sub n, actually, maybe it'll help you realize exactly what you're doing, and so you can have confidence in it and not just plug stuff in mindlessly. Okay, so R sub n equals 3 times 1/6 to the n minus 1. Because R is the common ratio and R sub 1 is the initial value. Don't get those R's confused. Sorry. And now I say, what's R sub 9? Well, it's 3 times 1/6 to the 9 minus 1. I have no idea what that is, so I grab my calculator. I say 3. Oh, my chubby little fingers on my little iPhone Desmos app. By the way, if you don't know, there is a Desmos app for phone. Oh boy. That's a yucky fraction. Holy goodness. That's a 1/559872. Criminy. Okay. All right. We'll move on. Done and done. Oh, let's get to the actual interesting part of the quiz. Sorry. No offense to arithmetic and geometric. They're just kind of easy. I don't know. I know I probably shouldn't say that, but just wait till calculus, guys. Wait till calculus, and then you can talk about this. Oh, yes. And talk about the series of that. Oh, yeah. Just wait. Oh, it's going to be fantastic. Just wait till you're writing this in your notes. Oh, it's going to be lovely. You got to take calculus, guys. You gotta. Okay, here we go. I got excited there. I say if f of x is this and g of x is that, are f and g inverses of each other? No. Just kidding. I don't know. We have to figure this out. Right? Explain, right? See how it says explain. So how do we do this? Well, star. If f of g of x equals g of f of x, and they equal x, sorry, that's the last condition, then f and g are inverses. So I got to look at their composition. So I say, what is f of g of x? Well, f of x is negative 3x minus 5, so f of g of x is negative 3g of x minus 5, because I'm just substituting x, right? And then g of x in question is negative 3, okay, here, times 1 minus x over 3 plus 2, sorry, plus 2, and then minus 5. Okay, well, let's do that distribution. I should get 1 minus x, so I see this here, and then minus negative 3 times 2 is negative 6, and then minus 5. So that is 1 minus negative x minus 10. Okay, so already I know, no, it doesn't. Let's do g of f of x. And I would say just to be sure, but we are sure it's no. Yeah, it's already plainly and flatly no. They aren't inverses, but we'll go ahead and plug it in anyway. Yeah. So we'll do g of f of x, and we'll do, let's see, so that is 1 minus f of x over 3 plus 2. You say, where are you getting that, Mr. Big? I say up here. It's right here. The input is x, so it's this x right here. So if the input is f of x, I put f of x there. Yeah? Let's replace it. And so now I do 1 minus f of x is negative 3x minus 5. This is over 3 and then plus 2. We'll do some operations here. Was that 1 plus 3x plus 5 over 3 plus 2. So that's 3x plus 6 over 3 plus 2, which is x plus 2 plus 2, which is x plus 4. I'm going to say big, fat, no. They are not inverses. Okay? No. And you say, why? Why? Because f of g of x is not equal to g of f of x. That is not true. Okay? This guy, a little ellipse. And this guy, little ellipse, are not equal. Done. We move on. If they were equal to x, both of them, that would mean they're inverses. But they're not. So they aren't. Okay. Last one here for the function below. State whether the function is 1-to-1. If it's not 1-to-1, give a reasonable restriction on the domain such the function is 1-to-1. So look at the first one. This is linear. So yes, it is 1-to-1. You say, how do you know that so immediately? You speak. Hey, guess what linear is? It's that. It's a line. That's always 1-to-1. Absolutely, of course, for sure. No doubt about it. There's no way you can bend a linear to not be 1-to-1. It's just that straight line like this every time. It doesn't even matter if you flip flat like this, right? You say, well, what if I did this? I say, well, that's not a function. So we don't even care about that. All right. All right, guys. No. There's an exception to this I didn't think about. I regret my pompous attitude. That's not 1-to-1, is it? Because that is a horizontal line. So by definition, it fails the horizontal line test. It is a horizontal line. So not necessarily true that all linears, but I'll say this. Negative slope passes, I'm going to say horizontal line test, so is 1-to-1. Maybe be careful there, right? Because look, you could make y equals 2. That's a linear function, and that by definition is not 1-to-1. So, careful there. All right. F of x equals exponential. Okay, now I think this is exponential. If you know your parent functions for exponential, right? Okay, so like that's a linear, right? It's a straight line like that. Exponential is going to grow like this. So that passes it. Yeah. It passes the horizontal line test. So it is 1-to-1. The last one. Oh. State whether the function is 1-to-1. Yes. LOL. Oops. This isn't a very good practice quiz. Okay, here's the reason. Here, that's a square root function, right? A square root is 1-to-1. Yes. Whoops, I meant to throw one on here that's not. Whoopsies. Okay, here, let me show you one. I'm going to make a D. I'm just going to make it up real quick here. D. I'm going to say f of x equals 3. I'm going to say like x minus 7 squared. Okay, that's quadratic. Quadratic fails the horizontal line test, right? So quadratic fails horizontal line test. So no, not 1-to-1. And so, and the reason I needed to do this is because it asks to give a domain restriction. Well, if you look at x minus 7 squared, that's a shift right 7. So it looks like this, somewhere here, upwards like this. You need only one of those legs. So I might erase that leg. And so I'll say my domain restriction is from that 7 onward to the right. So I'll say my domain restriction is x is greater than or equal to 7. And there you go. Oh boy, messed that up. Whatever. Good thing I didn't print the quiz. I think the actual quiz is like that too. Okay, bonus. And I'll do the bonus just for funsies here. I say given f of x equals x squared and g of x equals 1 over x, find the domain and range of h if h of x equals g composed with f of x. Justify your answer using complete sentences. Well, if h of x equals g composed with f of x, then that's g of f of x. So that's g of x squared. So that's 1 over x squared. That's the graph we are looking at. So h of x equals 1 over x squared. And if I wanted to get a sketch of this, right, I could maybe make a table. So I could say x and h of x. So if obviously I can't plug in 0. If I plug in -2, I get 1/4. If I plug in -1, I get 1. If I get 1, I get 1. I get 2, I get 1/4. I plug in 3, I get 1/9. If I plug in -3, I get 1/9 because I'm squaring all that. So if I were to sketch a graph, I know 0 doesn't exist, right? Because I can't do 1 over 0 squared. So I do still have a vertical asymptote here at 0 because it's rational, right? I should have a horizontal here because the degree of the denominator is more than the numerator. But what's happening, right, is it's like 1, 1 is right here. The -2, 1/4 is here, then down here. And if you do fractions, right, 1/2, I'm going to get 4. If you do -1/2, I'm also going to get 4. So 1/2 will be up here, and 1/2 will be up here, and like so. So the graph should look something like this. Sketch it like this. See how this is just a rough estimation? Say, woo! Let's curve this bad boy down. Make those nice little points there. Say, woohoo! There's that fella. I curve this guy this way, like so. My iPad is dying. And that should be enough to help me figure out domain and range, right? Domain, it only doesn't touch that vertical asymptote. So it is negative infinity to 0, union 0 to infinity. And the range, however, it's not at negative infinity, right? There's nothing down here. So actually the range starts at 0 and goes up to infinity. And that's your domain and range for this graph. Ain't that cool? Ain't that nifty? Alrighty. There it is. Hope you enjoyed. Hope it's helpful. This is going to be a group quiz. Don't fail it. Thank you. Bye.